Today I'm going to talk about linear differential equations with constant coefficient. Let's just take one of second order, namely 2y double prime minus 3y prime plus y equal to 0. First we get the auxiliary polynomial by mimicking powers of our derivative with powers of, say, some letter constant m. So I'm going to call my auxiliary polynomial in the variable m phi of m. So phi of m is equal to 2m squared minus 3m plus 1 to correspond to 2y double prime minus 3y prime plus y equal to 0. So I got my polynomial from that differential equation. It factors, and the roots are 1/2 and 1. So the complementary solution is C-O-M-P-L-I, not E. The complementary solution becomes y sub c is equal to c sub 1 e to the 1/2 x plus c2 e to the x, because my roots were 1/2 and 1 to my auxiliary polynomial. Now let's up the ante and look at 2y triple prime plus y double prime plus 3y prime plus 2y equal to 0. The auxiliary polynomial is enormous. Its phi of m is 2m cubed plus 5m squared plus 3m plus 2. Well, you can't factor a cubit right offhand, so you're going to have to use synthetic division. That's just by the rational root theorem, try -2. I'm just taking ratios of the constant term over the leading coefficient. Well, and one of them, of course, is 1 as a factor. And just using factors of those two terms, the constant term and the leading coefficient. So I'm going to do -2 divided by 1 anyway. It's just -2. I write down the decreasing, the coefficient of the decreasing powers of m. And lo and behold, I actually get something that works out. So 2m cubed plus 5m squared plus 3m plus 2 factors into m plus 2 times 2m plus m plus 1. And the 2m plus m plus 1 has to be figured in its factoring using the discriminant of a quadratic polynomial. And when you factor the thing and you get your complex roots, first of all, your complementary solution, if your complex root turned out to be in the form alpha plus I beta, your complementary solution then takes the form a e to the alpha of x cosine beta x plus d e to the alpha of x sine beta x. Notice where the alpha goes. As the constant in front of the x, that's the exponent on your exponential e. And then you got cosine beta x sine beta x, okay? So putting all this together, I come up with solving 2m squared plus m plus 1 using the quadratic formula, and it works out itself to have the root m equal to -1/4 plus or minus the square root of 7/4 I. So now I know what my overall solution is going to be. It's going to be y sub c is equal to c1 e to the -2x from the m plus 2 term, and then from the 2m squared plus m plus 1 term, I'm going to get c2 e to the -1/4 x cosine square root of 7 divided by 4x plus c3 e to the -1/4 x sine square root of 7 divided by 4x. And voila, that is the solution to that third order linear differential equation with constant coefficient. This is my first lecture. My second lecture is going to solve equations where I have repeated roots, and then I'm going to move on in lecture 3 to looking at the method of undetermined coefficient to solve those that are not homogeneous but non-homogeneous. Voila!